So this is an example of how to use the product rule. The product rule works when you have two differentiable functions, f and g, that are being multiplied together, and as a result, their derivative is also differentiable and can be found by using the product rule. This function is an example of how we can use the rule to find the derivative. There's two ways. I mean, you could technically distribute this all out and then use the power rule, but when you get into more complicated products, it's easier actually just to use the product rule. In order to do that, we do need to split this up into the two parts, the two functions that are being multiplied that are differentiable. And let's just call them g and h, just so they don't match our f of x that we have in the beginning here. In order to use the product rule, we do have to also find the derivative of g of x and the derivative of h of x. Derivative of g of x, and again we can use our power rules for this, 12x cubed, so 4 times your 3, and then 4 minus 1, so you go down by 1, minus 6x squared, again 2 times your 3, and then your 3 goes down a degree, plus 10x, again 2 times 5, 2 minus 1, and the constant disappears. We also require h prime of x, our derivative of h, which then becomes 4x cubed minus 9x squared. Again, 4 comes in front, 4 minus 1, that's how you get your 4x cubed, and your 3 times your negative 3, and 3 minus 1 is 2. Now that we have both of those, we can then take the derivative. Right now we have our function f of x, which is the product of g of x times h of x. So because we have these two functions that are being multiplied at the moment, if we want to use the product rule, then we're going to take the first function times the derivative of the second, add the derivative of the first times the multiplied by the actual function h of x. Then we can use what we have up above to plug in what we know. So the derivative of f of x is then going to be g of x, which is part of the original function, times by the derivative of h of x, which we came up with 4x cubed minus 9x squared. Then we add the derivative of g of x, so then we get here 12x cubed minus 6x squared plus 10x, and that's multiplied by h of x, which doesn't change from their original as well. Now the nice thing about the product rule is really and truly you can mix them around. Multiplication can go either way, addition doesn't change the signs. So if you haven't memorized the first one, then that's times the derivative of the second one plus the derivative of the first one times by the second. You can switch it up as long as one's the product of one of the originals times the derivative of the other one, and it's the sum of the two. At this point here, you'll want to then combine your, distribute your brackets and combine your like terms. To save a little bit of time, I just distributed that all out, and then you get this long polynomial plus another polynomial. After that, combine your like terms, and then you are done. And again, just to speed things up, there would be your simplified form. If we were to look at the original and actually distribute it, you'd find that you'd actually end up at the same point. So by using either the product rule, or if you distribute and use the power rule, either way, you would get the exact same thing.